Recycling is the process of converting waste materials into reusable objects to prevent waste of potentially useful materials, reduce the consumption of fresh raw materials, energy usage, air pollution and water pollution by decreasing the need for conventional waste disposal and lowering greenhouse gas emissions compared to plastic production. Recycling is a key component of modern waste reduction and is the third component of the reduce, reuse and recycle waste hierarchy. There are some ISO standards related to recycling such as ISO 15270-2008 for plastics waste and ISO 14001-2004 for environmental management control. Recycling practice. Recyclable materials include many kinds of glass, paper, metal, plastic, tires, textiles and electronics. The composting or other reuse of biodegradable waste, such as food or garden waste, is also considered recycling. Materials to be recycled are either brought to a collection center or picked up from the curbside, then sorted, cleaned and reprocessed into new materials destined for manufacturing. In the strictest sense, recycling of a material would produce a fresh supply of the same material. For example, used office paper would be converted into new office paper, or used polystyrene foam into new polystyrene. However, this is often difficult or too expensive, so recycling of many products and materials involves the reuse in producing different materials instead. Another form of recycling is the salvage of certain materials from complex products, either due to their intrinsic value, or due to the hazardous nature. History. Origins. Recycling has been a common practice for most of human history, with recorded advocates as far back as Plato in 400 BC. During periods when resources were scarce, archaeological studies of ancient waste dumps show less household waste, implying more waste was being recycled in the absence of new material. In pre-industrial times, there is evidence of scrap bronze and other metals being collected in Europe and melted down for perpetual reuse. Paper recycling was first recorded in 1031, when Japanese shops sold repulped paper. In Britain, dust and ash from wooden coal fires was collected by dustmen and downcycled as a base material used in brick making. The main driver for these types of recycling was the economic advantage of obtaining recycled feedstock instead of acquiring virgin material, as well as a lack of public waste removal in even more densely populated areas. In 1813, Benjamin Law developed the process of turning rags into shoddy and mungard wool in Batley, Yorkshire. This material combined recycled fibres with virgin wool. The West Yorkshire shoddy industry in towns such as Batley and Dewsbury lasted from the early 19th century to at least 1914. Industrialization spurred demand for affordable materials. Aside from rags, ferrous scrap metals were coveted as they were cheaper to acquire than virgin ore. Railroads both purchased and sold scrap metal in the 19th century, and the growing steel and automobile industries purchased scrap in the early 20th century. Many secondary goods were collected, processed, and sold by peddlers who scoured dumps and city streets for discarded machinery, pots, pans and other sources of metal. By World War I, thousands of such peddlers roamed the streets of American cities, taking advantage of market forces to recycle post-consumer materials back into industrial production. Beverage bottles were recycled with a refundable deposit at some drink manufacturers in Great Britain and Ireland around 1800, notably Schweppes. An official recycling system with refundable deposits was established in Sweden for bottles in 1884 and aluminum beverage cans in 1982. The law led to a recycling rate for beverage containers of 84 to 99%, depending on type. and a glass bottle can be refilled over 20 times on average. Wartime. New chemical industries created in the late 19th century both invented new materials and promised to transform valueless into valuable materials. Proverbially, you could not make a silk purse of a sowsia until the U.S. firm R&D Little published in 1921 on the making of silk purses from sowsias. Its research proving that when chemistry puts on overalls and gets down to business, new values appear. New and better paths are open to reach the goals desired. Recycling was a highlight throughout World War II. During the war, financial constraints and significant material shortages due to war efforts made it necessary for countries to reuse goods and recycle materials. These resource shortages caused by the world wars and other such world-changing occurrences greatly encouraged recycling. The struggles of war claimed much of the material resources available, leaving little for the civilian population. It became necessary for most homes to recycle the waste, as recycling offered an extra source of materials allowing people to make the most of what was available to them. Recycling household materials meant more resources for war efforts and a better chance of victory. Massive government promotion campaigns were carried out in the home front during World War II in every country involved in the war, urging citizens to donate metals and conserve fiber as a matter of patriotism. Post-war, a considerable investment in recycling occurred in the 1970s due to rising energy costs. Recycling aluminum uses only 5% of the energy required by virgin production. Glass, paper and metals have less dramatic but very significant energy savings when recycled feedstock is used. Although consumer electronics such as the television have been popular since the 1920s, recycling of them was almost unheard of until early 1991. The first electronic waste recycling scheme was implemented in Switzerland, beginning with collection of old refrigerators but gradually expanding to cover all devices. After these schemes were set up, many countries did not have the capacity to deal with the sheer quantity of e-waste they generated or its hazardous nature. They began to export the problem to developing countries without enforced environmental legislation. This is cheaper, as recycling computer monitors in the United States costs 10 times more than in China. Demand in Asia for electronic waste began to grow when scrapyards found that they could extract valuable substances such as copper, silver, iron, silicon, nickel and gold during the recycling process. The 2000s saw a large increase in both the sale of electronic devices and the growth as a waste stream. In 2002, e-waste grew faster than any other type of waste in the EU. This caused investment in modern, automated facilities to cope with the influx of redundant appliances, especially after strict laws were implemented in 2003. As of 2014, the European Union has about 50% of world share of the waste and recycling industries, with over 60,000 companies employing 500,000 persons, with a turnover of 24 billion euros. Countries have to reach recycling rates of at least 50%, while the lead countries are around 65% and the EU averages 39% as of 2013. Legislation. Supply. For a recycling program to work, having a large, stable supply of recyclable material is crucial. 3 legislative options have been used to create such a supply: mandatory recycling collection, container deposit legislation and refuse bans. Mandatory collection laws set recycling targets for cities to aim for, usually in the form that a certain percentage of a material must be diverted from the city's waste stream by a target date. The city is then responsible for working to meet this target. Container deposit legislation involves offering a refund for the return of certain containers, typically glass, plastic and metal. When a product in such a container is purchased, a small surcharge is added to the price. This surcharge can be reclaimed by the consumer if the container is returned to a collection point. These programs have been very successful, often resulting in an 80% recycling rate. Despite such good results, the shift in collection costs from a local government to industry and consumers has created strong opposition to the creation of such programs in some areas. A variation on this is where the manufacturer bears responsibility for the recycling of the goods. In the European Union, the WEEE directive requires producers of consumer electronics to reimburse the recycler's costs. An alternative way to increase supply of recyclates is to ban the disposal of certain materials as waste, often including used oil, old batteries, tires and garden waste. One aim of this method is to create a viable economy for proper disposal of banned products. Care must be taken that enough of these recycling services exist, or such bans simply lead to increased illegal dumping. Government-mandated demand legislation has also been used to increase and maintain a demand for recycled materials. Four methods of such legislation exist: minimum recycled content mandates, utilization rates, procurement policies, and recycled product labeling. Both minimum recycled content mandates and utilization rates increase demand directly by forcing manufacturers to include recycling in their operations. Content mandates specify that a certain percentage of a new product must consist of recycled material. Utilization rates are a more flexible option. Industries are permitted to meet the recycling targets at any point of their operation or even contract recycling out in exchange for tradable credits. Opponents to both of these methods point to the large increase in reporting requirements they impose, and claim that they rob industry of necessary flexibility. Governments have used their own purchasing power to increase recycling demand through what are called procurement policies. These policies are either set-asides, which reserve a certain amount of spending solely towards recycled products, or price preference programs which provide a larger budget when recycled items are purchased. Additional regulations can target specific cases. In the United States, for example, the Environmental Protection Agency mandates the purchase of oil, paper, tires and building insulation from recycled or re-refined sources whenever possible. The final government regulation towards increased demand is recycled product labeling, when producers are required to label the packaging with amount of recycled material in the product. Consumers are better able to make educated choices. Consumers with sufficient buying power can then choose more environmentally conscious options. Prompt producers to increase the amount of recycled material in the products, and indirectly increase demand. Standardized recycling labeling can also have a positive effect on supply of recyclates if the labeling includes information on how and where the product can be recycled. Recyclates. Recyclate is a raw material that is sent to, and processed in a waste recycling plant or materials recovery facility which will be used to form new products. The material is collected in various methods and delivered to a facility where it undergoes remanufacturing so that it can be used in the production of new materials or products. For example, plastic bottles that collected can be reused and made into plastic pellets, a new product. Quality of recyclate. The quality of recyclates is recognized as one of the principal challenges that needs to be addressed for the success of a long-term vision of a green economy and achieving zero waste. Recyclate quality is generally referring to how much of the raw material is made up of target material compared to the amount of non-target material and other non-recyclable material. Only target material is likely to be recycled. so a higher amount of non-target and non-recyclable material will reduce the quantity of recycling product. A high proportion of non-target and non-recyclable material can make it more difficult for reprocessors to achieve high-quality recycling. If the recyclate is of poor quality, it is more likely to end up being downcycled or, in more extreme cases, sent to other recovery options, a landfill. For example, to facilitate the remanufacturing of clear glass products, there are tight restrictions for colored glass going into the remelt process. The quality of recyclate not only supports high-quality recycling, but it can also deliver significant environmental benefits by reducing, reusing and keeping products out of landfills. High-quality recycling can help support growth in the economy by maximizing the economic value of the waste material collected. Higher income levels from the sale of quality recyclates can return value which can be significant to local governments, households and businesses. Pursuing high-quality recycling can also provide consumer and business confidence in the waste and resource management sector and may encourage investment in that sector. There are many actions along the recycling supply chain that can influence and affect the material quality of recyclate. It begins with the waste producers who place non-target and non-recyclable wastes in recycling collection. This can affect the quality of final recyclate streams and require further efforts to discard those materials at later stages in the recycling process. The different collection systems can result in different levels of contamination, depending on which materials are collected together. Extra effort is required to sort this material back into separate streams and can significantly reduce the quality of the final product. Transportation and the compaction of materials can make it more difficult to separate material back into separate waste streams. Sorting facilities are not 100% effective in separating materials. Despite improvements in technology and quality recyclate which can see a loss in recyclate quality, the storage of materials outside where the product can become wet can cause problems for reprocessors. Reprocessing facilities may require further sorting steps to further reduce the amount of non-target and non-recyclable material. Each action along the recycling path plays a part in the quality of recyclate. Quality Recyclate Action Plan. The Recyclate Quality Action Plan of Scotland sets out a number of proposed actions that the Scottish Government would like to take forward in order to drive up the quality of the materials being collected for recycling and sorted at materials recovery facilities before being exported or sold on to the reprocessing market. The plan's objectives are to drive up the quality of recyclate, deliver greater transparency about the quality of recyclate, provide help to those contracting with materials recycling facilities to identify what is required of them, ensure compliance with the Waste Regulations 2012, stimulate a household market for quality recyclate, address and reduce issues surrounding the waste shipment regulations. The plan focuses on 3 key areas with 14 actions which were identified to increase the quality of materials collected, sorted and presented to the processing market in Scotland. The 3 areas of focus are collection systems and input contamination, sorting facilities, material sampling and transparency, material quality benchmarking and standards, recycling consumer waste collection. A number of different systems have been implemented to collect recyclates from the general waste stream. These systems lie along the spectrum of trade-off between public convenience and government ease and expense. The 3 main categories of collection are drop-off centers, buyback centers, and curbside collection. Curbside collection encompasses many subtly different systems, which differ mostly on where in the process, the recyclates are sorted and cleaned. The main categories are mixed waste collection, commingled recyclables, and source separation. A waste collection vehicle generally picks up the waste. At one end of the spectrum is mixed waste collection, in which all recyclates are collected mixed in with the rest of the waste, and the desired material is then sorted out and cleaned at a central sorting facility. This results in a large amount of recyclable waste, paper especially, being too soiled to reprocess, but has advantages as well. The city need not pay for a separate collection of recyclates, and no public education is needed. Any changes to which materials are recyclable is easy to accommodate, as all sorting happens in a central location. In a commingled or single-stream system, all recyclables for collection are mixed but kept separate from other waste. This greatly reduces the need for post-collection cleaning, but does require public education on what materials are recyclable. Source separation is the other extreme, where each material is cleaned and sorted prior to collection. This method requires the least post-collection sorting and produces the purest recyclates, but incurs additional operating costs for collection of each separate material. An extensive public education program is also required, which must be successful if recyclate contamination is to be avoided. Source separation used to be the preferred method due to the high sorting costs incurred by commingled collection. Advances in sorting technology, however, have lowered this overhead substantially. Many areas which had developed source separation programs have since switched to commingled collection. Buyback centers. Buyback centers differ in that the cleaned recyclates are purchased, thus providing a clear incentive for use and creating a stable supply. The post-processed material can then be sold on, hopefully creating a profit. Unfortunately, government subsidies are necessary to make buyback centers a viable enterprise, as according to the U.S. National Waste and Recycling Association, it costs on average $50 to process a ton of material, which can only be resold for $30. Drop-off centers. Drop-off centers require the waste producer to carry the recyclates to a central location, either an installed immobile collection station of the reprocessing plant itself. They are the easiest type of collection to establish, but suffer from low and unpredictable throughput. Distributed recycling. For some waste materials such as plastic, recent technical devices called recycle bots enable a form of distributed recycling. Preliminary life cycle analysis indicates that such distributed recycling of HDPE to make filament of 3D printers in rural regions is energetically favorable to either using virgin resin or conventional recycling processes because of reductions in transportation energy. Sorting. Once commingled recyclates are collected and delivered to a central collection facility, the different types of materials must be sorted. This is done in a series of stages, many of which involve automated processes such that a truckload of material can be fully sorted in less than an hour. Some plants can now sort the materials automatically, known as single-stream recycling. In plants, a variety of materials are sorted such as paper, different types of plastics, glass, metals, food scraps and most types of batteries. A 30% increase in recycling rates has been seen in the areas where these plants exist. Initially, the commingled recyclates are removed from the collection vehicle and placed on a conveyor belt spread out in a single layer. Large pieces of corrugated fiberboard and plastic bags are removed by hand at this stage, as they can cause later machinery to jam. Next, automated machinery such as disc screens and air classifiers separate the recyclates by weight, splitting lighter paper and plastic from heavier glass and metal. Cardboard is removed from the mixed paper, and the most common types of plastic, PET and HDPE, are collected. This separation is usually done by hand but has become become automated in some sorting centers. A spectroscopic scanner is used to differentiate between different types of paper and plastic based on the absorbed wavelengths, and subsequently divert each material into the proper collection channel. Strong magnets are used to separate out ferrous metals, such as iron, steel and tin cans. Non-ferrous metals are ejected by magnetic eddy currents, in which a rotating magnetic field induces an electric current around the aluminum cans, which in turn creates a magnetic eddy current inside the cans. This magnetic eddy current is repulsed by a large magnetic field, and the cans are ejected from the rest of the recyclate stream. Finally, glass is sorted according to its color: brown, amber, green or clear. It may either be sorted by hand, or via an automated machine that uses colored filters to detect different colors. Glass fragments smaller than 10 mm across cannot be sorted automatically, and are mixed together as glass fines. This process of recycling as well as reusing the recycled material has proven advantageous because it reduces amount of waste sent to landfills, conserves natural resources, saves energy, reduces greenhouse gas emissions and helps create new jobs. Recycled materials can also be converted into new products that can be consumed again, such as paper, plastic and glass. The City and County of San Francisco's Department of the Environment is attempting to achieve a citywide goal of zero waste by 2020. San Francisco's refuse hauler, Recology, operates an effective recyclable sorting facility in San Francisco, which helped San Francisco reach a record-breaking diversion rate of 80%. Rinsing food packaging should no longer contain any organic matter, since no trace of biodegradable material is best kept in the packaging before placing it in a trash bag. Some packaging also needs to be rinsed.